vectors. In that, we will see some examples from exercise 5.2. The first example is find the position vector of the point R which divides the line segment joining the points P and Q, whose position vectors are 2i minus j plus 3k and minus 5i plus 2j minus 5k in the ratio 3:2 internally and externally. So how to solve this? Let P bar and Q bar be the position vectors of the points P and Q respectively. So P bar is equal to this 2i minus j plus 3k and Q bar is equal to minus 5i plus 2j minus 5k. Also, it is given that the ratio is m/n is given to be 3:2. Now the first problem, let R of R bar is the point which divides the segment PQ internally in the ratio 3:2. Okay, so by using the section formula for internal division, we can write it as R bar is equal to m q bar plus n p bar upon m plus n. So put the values of q bar, p bar and m and n, you will get this equation. So after simplifying it, R bar is equal to minus 15i plus 6j minus 15k plus 4i minus 2j plus 6k upon 5. So which implies R bar is equal to minus 11 upon 5 times I cap plus 4 upon 5 times j cap minus 9 upon 5 times k cap. So the coordinates of the point R which divides the segment PQ internally are given by minus 11 by 5, 4 by 5, minus 9 by 5. The second, suppose that point R of R bar divides the segment PQ externally in the ratio 3:2. So again we will use the section formula but for the external division. So R bar is equal to mq bar minus np bar upon m minus n. Again put the values, simplify it by this way, multiply by 3, multiply by 2, minus 2, 3 minus 2 is 1. So you will get R bar is equal to minus 19i plus 8j minus 21k. So the coordinates of the point R which divides PQ externally are given by minus 19, 8 and minus 21. The second problem is find the position vector of the midpoint M joining the points L 7 minus 6 12 and N 5 4 minus 2. You have to find the coordinates of the point M. You have to find the coordinates of the point M. Here it is L, here it is N, and here it is somewhere M. We have to find this ratio and this ratio at which this divides. Okay, so how to find? Let what is given, L is given and N is given and M is the midpoint of the segment Ln. So let L bar, M bar, N bar be the position vectors of the points L, M, N respectively, which implies L bar must be equal to 7i minus 6j plus 12k and N bar must be equal to 5i cap plus 4j cap minus 2 cap k cap. So by using midpoint formula, M bar is equal to L bar plus N bar upon 2. Put the vectors, take their addition, you'll get 12i minus 2j plus 10k upon 2 divided by 2. Then we get M bar is equal to 6i minus j plus 5k. Therefore, the coordinates of the point M which divides Ln in at or M is the midpoint of the segment Ln is 6, minus 1 and 5. The third example is if the points A 30P, B -1 Q3, C -330 are collinear, then find the ratio in which the point C divides the line segment AB, the values of P and Q. Okay. Now how to solve? Let A bar, B bar, C bar be the position vectors of the points P, Q, A, B and C respectively. So which implies A bar is equal to 3I plus 0J plus PK, B bar is equal to -I plus QJ plus 3K, C bar is equal to -3I plus 3J plus 0K. Now it is given that they are collinear. A, B, C are collinear. That means C divides the segment AB in the ratio M is to N. As the points A, B, C are collinear, we can take this. The point C divides AB. We don't know whether it is divided internally or whether it is divided externally, but they are collinear, so C must be divided in some internal or external. We take that ratio as M is to 1. So by using section formula for internal division, we get C bar is equal to MB bar plus 1A bar upon M plus N. Now put the values of C bar, B bar and A bar. Take this M plus 1 to this side. Multiply this bracket by M, this bracket by 1. Now take the coefficients of I to get together, J together and KK together. So at the same time multiply this M plus 1 inside this bracket. So by equating the corresponding components, means equate I component, equate JJ component and equate KK component, you will get -3 times M plus 1 is equal to -M plus 3, and similarly this is J component, then this is K component. After equating this from equation 1, we can simplify it to get the value of M. So we get M is equal to -3. Now put this -3 in equation number 2 so that we can find the value of Q. It is 2. And now finally substitute the value of M is equal to -3 in equation number 3 so that we can find the value of P. We get P is equal to -9. So C divides the segment AB externally in the ratio 3:1. Also, what the value of P is 9 and value of Q is 2. Now next, the position vector of point A and B are 6A bar plus 2B bar and A bar minus 3B bar. If the point C divides AB in the ratio 3:2, then show that the position vector of C is 3A bar minus B bar. Let P bar, Q bar, R bar be the position vectors of the points A, B and C respectively. Okay. So it is given that P bar is 6A bar plus 2B bar, Q bar is A bar minus 3B bar, and also the point C divides AB internally in the ratio 3:2. So M is to N is given that 3:2. C divide the segment AB in the ratio 3:2. So we use the section formula for internal division. R bar is equal to 3Q bar plus 2P bar upon 3 plus 2. Put the values of Q bar and P bar. We get R bar is equal to 3A bar minus 9B bar plus 12A bar plus 4B bar upon 5. That is R bar is equal to 15A bar minus 5B bar upon 5. That is R bar is equal to 3A bar minus B bar, which is the required. As required, we want to show that the position vector of the point C is 3A bar minus B bar. The next example is prove that the line segments joining the midpoints of the adjacent sides of the quadrilateral form a parallelogram. This theorem you have proved in the class 9th or 10th. So how to prove? Now consider the quadrilateral ABCD, where PQRS be the midpoints of the sides AB, BC, CD and DA respectively. You can see this in the figure. ABCD is the quadrilateral. PQRS are the midpoints of which sides? P is the midpoint of AB, Q is the midpoint of BC, R is the midpoint of CD, and S is the midpoint of AD. Okay. So let A bar, B bar, C bar, D bar, P bar, Q bar, R bar, S bar be the position vectors of the points A, B, C, D, P, Q, R, S respectively. Okay. So the by using midpoint formula, we can write this P bar as A bar plus B bar upon 2, Q bar as B bar plus C bar upon 2, R bar as D bar plus C bar upon 2, S bar as A bar plus B bar up, A bar plus D bar upon 2. So what we get? PQ bar is equal to position vector of the point Q minus position vector of the point P, Q bar minus P bar, which is equal to B bar plus C bar upon 2 minus A bar plus B bar upon 2. We put the values of P bar and Q bar. Now their denominators are same, so we have to take the subtraction of the numerator. So 1/2 B bar plus C bar minus A bar minus B bar, that is PQ bar is equal to 1 upon 2 C bar minus A bar, because B bar and minus B bar will get cancelled. By this way you get the value of PQ bar, equation number 1. Now similarly, yes, R bar minus S bar is C bar plus D bar upon 2 minus A bar plus D bar upon 2 is equal to 1 upon 2 C plus D minus A minus D. Again D gets cancelled. You will get S R bar is equal to 1 upon 2 C bar minus A bar, which is our equation number 2. Now QR bar is equal to R bar minus Q bar. So C bar plus D bar upon 2 minus B bar plus C bar upon 2 is equal to 1/2 C bar plus D bar minus B bar plus C bar upon 2. So we get QR bar is equal to 1 upon 2 times D bar minus B bar, which is our equation number 3. PS bar is S bar, position vector of the second point minus position vector of the first point. So S bar minus P bar is A bar plus D bar upon 2 minus A bar plus B bar upon 2 is equal to 1 upon 2 times A bar plus D bar minus A bar minus B bar. Here A bar will get cancelled and you will get PS bar is equal to 1 upon 2 times D bar minus B bar. Okay. This is our equation number 4. Now from equation 1 and 2 we can get from equation 1 and from equation 2 their right hand sides are same, so left hand side must be same. So we get PQ bar is equal to SR bar. That means they are parallel, they are equal. That means their vectors are equal. When we say that if vectors are equal, if they are parallel and they are having same magnitude, so PQ bar is parallel to SR bar. From equation 3 and 4, they are also their right hand side are also same. So QR bar is equal to PS bar. So QR bar is parallel to PS bar. So from equation 1 and 2, this small 1 and small 2, opposite sides of the quadrilateral PQRS are parallel and equal. But this equation tells us that the opposite sides of the quadrilateral are parallel, and equality says that their magnitudes are same. That means their length is same. Hence, the quadrilateral PQRS is a parallelogram. Okay. 6th example, D and E divides sides BC and CA of the triangle ABC in the ratio 2:3 respectively. Find the position vector of the point of intersection of AD and BE and the ratio in which the point divides AD and BE. Consider the triangle ABC as shown in the figure. Given that DE divides BC and CA in the ratio 2:3. This is the point D, this is the point E. So D divides this BC in the ratio 2:3, and this is the point E which divides CA in the ratio 2:3. Okay, and their point of intersection is P, and we are saying that this P divides this BE in the ratio n is to 1, and this P divides the ratio AD in the ratio m is to 1. Let A bar, B bar, C bar, D bar, E bar be the position vectors of the points A, B, C, D, E respectively with respect to origin. Now by the section formula, this D bar is equal to 2 times C bar plus 3 times B bar upon 2 plus 3. This E bar is equal to 2 times A bar plus 3 times C bar upon 2 plus 3. Let the point of intersection of AD and BE be P with the position vector P bar. This is the point of intersection of BE and AD. Let P divides AD in the ratio m is to n, and segment BE in the ratio n is to 1. Here it is m is to 1. It divides the segment AD in the ratio m is to 1 and the segment BE in the ratio n is to 1. So by using section formula for internal division, we get P bar is equal to m times D bar plus 1 times A bar upon m plus 1. So P bar is equal to, what is D bar? D bar is 2C bar plus 3B bar upon 5. Simplify it, we get P bar is equal to 2MC bar plus 3MB bar plus 5A bar upon 5 times m plus 1. So which implies P bar is equal to 5A bar 5 upon m plus 1 plus 3MB bar upon 5 times m plus 1 and plus 2MC bar upon 5 times m plus 1. This is our equation number 1. Also this P bar is equal to n times E bar plus 1 times B bar upon n plus 1. Now put the value of E bar in this equation. You get, what we get? We get P bar is equal to 2NA bar plus 3NC bar upon plus 5B bar upon 5 times n plus 1. Divide this divide by 5n plus 1 separately, you will get this equation 2NA bar upon 5 times n plus 1 plus 5B bar upon 5 times n plus 1 and plus 3 times NC bar upon 5 n plus 1. This is our equation number 2. Now, so from equation 1 and 2, equating the corresponding components. Equating the corresponding components means equate the coefficients of A bar, equate the coefficient of B bar, and equate the coefficient of C bar. After equating the coefficient of A bar, we get 5 upon 5 times m plus 1 is equal to 2n upon 5 times n plus 1. Equating the coefficients of B bar and C bar, we get these two equations. So now divide equation 2 by equation 3. Equation 2 by equation 3. We get this equation, and after simplifying it, you will get 3 by 2 is equal to 5 upon 3n. That means n is equal to 10 upon 9. Okay. So similarly, now divide equation 1 by equation 3. Divide this equation 1 by equation 3. We get m is equal to 15 upon 4. Hence, the point of intersection P divides segment AD internally in the ratio 15:4 and segment BE internally in the ratio 9:10:9. Now, to find the position vector of the point P bar, we have to find the position vector of the point P, which is P bar. So take from equation 1 or from equation 2. So you take any P bar and put the values of either m or n in that equation. We get this. So simplifying P bar is equal to 20 A bar plus 45 B bar plus 30 C bar upon 5 into 19. Again, further simplifying it, we get the position vector of the point P to be 1 upon 19 times 4 A bar plus 9 B bar plus 6 C bar. Okay. Seven. Prove that the quadrilateral is a parallelogram if and only if its diagonals bisect each other. This is one of the theorems you have learned in the secondary school. Now, how to prove this? Consider the quadrilateral ABCD. A, B, C, D. This is the quadrilateral. So let A bar, B bar, C bar, D bar be the position vectors of the points A, B, C, D respectively. So quadrilateral A, B, C, D is a parallelogram. To prove that the diagonals bisect each other, here it is if and only if part. So we have to assume this part and we have to prove this part. Then we have to assume this part and we have to prove the first part. So since ABCD is a parallelogram, AB bar must be equal to DC bar. Opposite sides are parallel and equal, which implies B bar minus A bar is equal to C bar minus D bar using the position vectors. So take this A bar to this side and this minus D bar to that side. We will get A bar plus C bar is equal to B bar plus D bar divided by 2, which is equal to say M bar. That means M is the point with the position vector M bar. Hence, M is the midpoint of the diagonal AC and diagonal BD. M is the midpoint. Punasa AC and BD. Yeah, down diagonals are. So, which implies diagonals AC and BD bisect each other. Now, conversely, let the diagonals of the quadrilateral ABCD bisect each other at the point N with the position vector N bar. Now, we are assuming that diagonals bisect each other. We have to prove that it is a parallelogram. Now, as N is the midpoint of the diagonals AC bar and BD bar, we get N bar is equal to A bar plus C bar upon 2 and B bar plus D bar upon 2. So, we will take only these two equalities and we will solve it. B bar minus A bar is equal to C bar minus, which implies AB bar is equal to DC bar, which implies AB bar and DC bar are parallel to each other and are of equal length, which implies opposite sides of the quadrilateral ABCD are equal and parallel. So, which implies a quadrilateral ABCD is a parallelogram. It proves the theorem. Hence, quadrilateral is a parallelogram if and only if diagonals bisect each other. Now, the next example is prove that the median of a trapezium is parallel to the parallel sides of the trapezium and its length is half the sum of the parallel sides. Already you have proved this theorem in the Cartesian form. How to prove this? So consider a trapezium ABCD with sides AB parallel to the side DC. This is your ABCD trapezium. Trapeziums AB is parallel to DC and ED and BC are not parallel. Let P and Q be the midpoints of the sides AD and BC respectively. AD, midpoint of this AD is P and midpoint of BC is Q. Now, which implies PQ is the median of the trapezium. You can see this in the figure. This PQ is the median of this triangle, trapezium ABCD. Let A bar, B bar, C bar, D bar, P bar, Q bar be the position vectors of the points A, B, C, D, P and Q respectively. Now, as it is a trapezium, so AB must be parallel to DC, which implies AB bar is parallel to DC bar in terms of a vector. So there exists a non-zero scalar M such that AB bar is equal to scalar multiple of DC bar. As they are parallel, that means they are collinear. So AB bar is equal to M times DC bar, which is our equation number 1. So using the midpoint formula, as P is the midpoint of AD, so P bar is equal to A bar plus D bar upon 2 and Q bar is equal to B bar plus C bar upon 2. So PQ bar is equal to Q bar minus P bar, position vector of the second point minus position vector of the first point. Using this, we get 1/2 B bar plus C bar minus A bar minus D bar. That means PQ bar is equal to 1 upon 2 times B bar minus A bar is in one bracket plus C bar minus D bar is in another bracket. Just group B bar and A bar in one bracket and C bar and D bar in another bracket, so that I can write PQ bar as AB bar and plus DC bar. PQ bar is equal to 1 upon 2. This B bar minus A bar is AB bar and C bar minus D bar is DC bar. So PQ bar is equal to 1 half m times dc bar. From equation 1, we are putting the value of AB bar plus DC bar. So take their addition, we get PQ bar is equal to m plus 1 upon 2 times DC bar. That means PQ bar is a scalar multiple of DC bar. And once we have proved that the PQ bar is a scalar multiple of DC bar, that means they are parallel. And as they are parallel, we have proved one part. So AB bar is parallel to DC bar implies PQ bar is parallel to AB bar. So PQ bar is parallel to AB bar and DC bar both. Also from equation 2, this equation is our equation number 2. AB bar and DC bar are collinear. AB bar and DC bar are collinear, which implies modulus of AB bar plus DC bar is same as modulus of AB bar plus modulus of DC bar, as they are collinear. And which implies modulus of PQ bar is equal to 1 upon 2 times modulus of AB bar plus DC bar, as they are lies along the same line. So their sum must be same. So from equation 1 and 2, this is our equation number 1 and this is our equation number 2. The median PQ of the trapezium ABCD is parallel to the parallel side AB bar and DC bar, and its length is half the sum of the parallel sides. Ninth example, if two of the vertices of the triangle A 3 1 4 and B minus 4 5 minus 3 and the centroid of the triangle is G minus 1 2 1, then find the coordinates of the third vertex C of that triangle. We will let the third vertex of the triangle is C, X, Y, Z. Now, therefore, we get the position vector of these points. A bar is 3i plus j plus 4k. B bar is minus 4i plus 5j. B bar is minus 4i plus 5j minus 3k. C bar is xi plus 5yj plus zk. J bar is minus I plus 2j plus k. Be the position vectors of the points A, B, C, and G respectively. Okay, so by using the formula of centroid of the triangle, what you will get? What is the formula for centroid of the triangle? G bar is equal to A bar plus B bar plus C bar upon 3. So we put all those A bar, B bar, C bar, and G bar in this formula. We get this equation. So after simplifying it, we get xi plus yj plus zk is minus 2i plus 0j plus 2k. Equating the components, we get x is equal to minus 2, y is equal to 0, and z is equal to 2. So this is the coordinates of the third vertex. 10th example, in triangle OAB, E is the midpoint of OB and D is the midpoint of AB, such that AD is to DB is 2:1. If OD and AE intersect at point P, then determine the ratio OP is to PD using vector method. Now consider triangle OAB. It is given that E is the midpoint of that OB and D divides AB in the ratio 2:1. You can see it in the figure. OAB is the triangle. E is the midpoint of OB. D divides AB in the ratio 2:1. Now let A bar, B bar, D bar, E bar be the position vectors of the points A, B, D, E respectively. Now, as by using the midpoint formula, this E bar is equal to O bar plus B bar, okay, upon 2. That means D bar upon 2. Also, by using section formula for internal division, as D divides AB internally in the ratio 2:1, so D bar is equal to 2B bar plus A bar upon 3. Equation number 2. Now also given point of intersection of OD and AE, OD and AE is P. So let P bar be the position vector of the point P. Now P divides the segment AE. P divides segment AE in the ratio n:1 and segment OD in the ratio m:1. So by using the section formula for internal division, P bar is equal to m d bar plus 1 times 0 bar upon m plus 1, which is equal to m times 2b bar plus a bar upon 3. P bar is equal to m a bar upon 3 times m plus 1 plus 2m b bar upon 3 times m plus 1 is our small equation number 1. Also, P is equal to n e bar plus 1 a bar. Now we use this P divides AE in the ratio n:1. Again, P bar is equal to n e bar plus 1 a bar upon n plus 1, which is equal to n times b bar by 2 plus a bar upon n plus 1, n b bar upon 2 a bar upon 2 times n plus 1 plus n b bar upon 2 times n plus 1, equation number 2. Now from equation 1 and 2, this is equation 1 and this is equation number 2. Equating the corresponding components, we get these two equations. Corresponding components means A bar check components and P bar check components. So these are the two equations. Now divide the equation 3 by equation 4. Now divide this equation by this equation. We get 1/2 is equal to n up 2 upon n. That is n is equal to 4. N is equal to 4 means this P divides AE in the ratio 4:1. P of P bar divides segment AE in the ratio 4:1. So now P bar is equal to 4 times B bar by 2 plus 1 times A bar upon 4 plus 1. So P bar is equal to 2 B bar plus A bar upon 5. But P bar is given to be this m times 2 B bar plus A bar upon 3 times m plus 1. Another. So hence 2 B bar plus A bar upon 5 is equal to m upon 3 times m plus 1 times 2 B bar plus A bar, which implies m upon 3 times m plus 1 is equal to 1 upon 5, which implies 5m is equal to 3m plus 3. So 2m is equal to 3. So m is equal to 3 upon 2. That means this P divides OD in the ratio 3:2. It divides in the ratio. Since OP upon PD, the required ratio, the OP upon PD is 3/2. 11th example, if the center of the tetrahedron OABC is 1, 2, minus 1, this is the centroid. So G bar, A is given A 2, 3, B is given 1, B 2, and C is given 2, 1, C respectively. Find the distance of the point P ABC from the origin. Now it is given that OABC is the tetrahedron. So let O bar is 0i plus 0j plus 0k. A bar is AI plus 2j plus 3k. And B bar is 1i plus bj plus 2k. C bar is equal to 2i plus j plus ck with the position vectors of the points O, A, B, and C respectively. Let G bar is equal to this with the centroid of the tetrahedron OABC. So we use the formula to find the position vector of the centroid of the tetrahedron. G bar is equal to A bar plus B bar plus C bar plus D bar upon 4. That means 4G bar is equal to A bar plus B bar plus C bar plus 0 bar. So put the values of G bar, A bar, B bar, C bar, and 0 bar. We get this equation. And after simplifying it, collecting the coefficients of I cap, J cap, K cap, we get 4i cap plus 8j cap minus 4k cap is equal to A plus 3 times I plus B plus 3 times J plus C plus 5 times K. So by the equality of the vectors, we get A plus 3 is equal to 4, B plus 3 is equal to 8, and C plus 5 is equal to minus 4. So from this equation, we get A is equal to 1, B is equal to 5, and C is equal to minus 9. So thus we get the coordinates of the point P, 1, 5, minus 9. And now we want to find the distance of this point P from the origin. That means distance OP. OP is equal to square root of x2 minus x1 bracket square plus y2 minus y1 bracket square plus z2 minus z1 bracket square. So 1 minus 0 bracket square plus 5 minus 0 bracket square plus 9 minus 9 minus 0 bracket square. So we get OP is equal to square root 1 plus 25 plus 81. It is nothing but OP is equal to square root of 107. So the distance of the point P from origin is square root of 107. The 12th example is find the centroid of the tetrahedron with vertices K 5 minus 7 0, L 1 5 3, M 4 minus 6 3 and N 6 minus 4 2. We have to find the centroid of this tetrahedron. So we will let A bar be the first vector, B bar is the second, C bar is the third, and D bar is the fourth vector with the position vectors of the points K, L, M, N respectively. So by the centroid of the triangle, centroid formula for trapezium of tetrahedron, Z bar is equal to A bar plus B bar plus C bar plus D bar upon 4. So put the A bar, B bar, C bar and D bar, take their addition, we get 16i minus 12j plus 8k upon 4 divided by 4i minus 3j plus 2k. Therefore the centroid of the tetrahedron is 4 minus 3, 2. This is the required centroid of the triangle.